All right, everybody here? Harry, can you hear me?
Yeah.
Gavin, your audio is off again. Okay.
Sorry, I had to do something. Back.
All right. So we've got identify it. How long is it? Arcs and sectors, inscribed, circles, reason it. So how long is it is probably like those chords that are, they're perpendicular to the radius. And so you're able to use the right triangles to figure it out, right? Arcs and sectors have to do with central angles. All right, Jason, I'm gonna let you go first.
Identify 200.
Identify 200. Name the chord parallel to the diameter of circle C.
No, I don't even understand the question. Name the chord that parallel to the diameter of C. Amen. Name the chord that parallel to the diameter of it.
Yep. So you got to send me some kind of text or you can physically raise your hand if you want to.
Name the chord that parallel to the diameter of that. What does it mean by parallel?
You guys got to answer. There's an easy one. Come on, it's easy.
Wait, can I like private texting? Is there any? Oh, there is.
No, that's everyone.
Oh, somebody he sent me a chat. Oh, can I even get a chat here?
Oh, chord, man.
Oh, I'm not sure I can. Yeah, the chat isn't showing up with this thing in full screen mode, so you're gonna have to raise your hand to tell me. You guys should be able to chat with each other though, like Harry and Gavin, if you want to chat with each other.
Right.
All right, somebody got it?
Yeah. Amen.
Harry, do you want to answer it?
Me?
Yeah.
MN. So Jason gets 200. All right, Jason, you still got the board.
How long is the 200?
Okay. So remember, guys, raise your hand if you have the answer. Find HG if CH equals CI, AC equals 13, and BE equals 24.
Where's C? Oh.
So you have to find this one at the bottom, this short one at the bottom.
Oh, right.
Right.
So this is about, it's a right triangle, right?
Oh, wait a second.
You got to find CH and subtract it from CG, basically.
Did you receive my text?
I can't receive texts while we're in this mode because the Mathardy thing takes up the whole screen. So you have to. Oh, I see your hand. I see your hand, though. I see your hand. Okay, so
right,
what's your answer?
5.
What's that?
5 feet.
5 feet. Okay. You guys have another answer, Gavin? I'll give you 10 seconds.
8 feet.
That is correct, Harry. So
how did you get it?
You had AC was your hypotenuse of 13 feet, right?
Oh,
AH was 12 feet. So 13, 12, that means CH is 5. So you subtract 5 from 13, that gives you 8. So the picture.
They're asking for HG. Oh.
Yeah, the picture's not to scale.
Oh.
The picture's not scale.
Oh.
So Gavin, you guys get 200 and you've got the board.
I thought you were asking for CH.
How long is it? 100?
Find AE if AB equals 6, EF equals 4, and CD equals 1. Yes, Jason.
Is that 15?
Yes. So you've got 12 plus 4 minus 1, right? AB is the diameter. EF, EC is a radius. You add those together, you subtract 1, and you get 15. So that gives you 300. Let me just check to see if anybody else is has. Oh, there's your chat. There's your chat popped up. Hide video panel. Show names, disable part. Okay. All right. So, Jason, you've got the board.
Circle 200.
Circles 200. Given a center of -2, and a radius of 2, square root of 2, find the equation of the circle. So this is going to be the x minus y minus.
I have a question. I have a question. Even I get the answer. How am I going to show you that?
Yeah, if you send me the chat, and I'll just assume that you're putting the squares in, or you can put in a 2 at the end, or you could write it down and put it up on your screen. Write it down and put it up on your screen.
Okay.
And it's all whole numbers. It's all integers. Just so you know.
All right, I'm just gonna text you.
Okay. I gotta make sure I can pull up the chat. The left part's pretty easy, right? Because you've got the center here.
Yeah.
And the right part, you just square the 2 squared, right? I mean, this is a pretty easy one.
Yeah. Where's the plus?
Am I blocking you here? I wonder if I can move this out of the way. Here we go. Do you guys see that chat there? That is correct. That is correct. So, Gavin, do you guys got it?
I forgot what's the formula for it again.
So
Wasn't there a formula for
you
it?
flip the sign, so it's x plus 2 parentheses squared,
Okay.
y minus 6. So you flip the signs, y minus 6 parentheses squared, and then you square the radius. So the square of 2 is
4, sorry.
and the square root of 2.
2.
So 2 times 4.
Which is 8. Oh, okay.
Yeah, so it's, whoops. So it's x plus 2 squared plus y minus 6 squared equals 8. So again, you know, some of this coordinate geometry stuff isn't as difficult as you might think it would be. All right, so that gets Jason up to 700. And you've got the board.
You got the board?
You do.
Okay. Arcs and sector 200.
Arcs and sectors 200. Find the area of a 60-degree sector with an 8-mile radius.
Am I texting you? Okay. Raise my hand first.
Yep.
Is there any pi on the keyboard? Do you know how to type it?
Yeah, it's you can get it. Oops, I can't get the chat box up here for some reason. Oh, there it is. All right, 32 pi over 3.
Oh, 32 over 3
What's your unit of measure though?
That's what is that MI, by the way?
Miles.
Miles squared. Wait, is that right? Miles squared?
Yep, miles squared. So the answer is 32 pi over 3 miles squared, and that is the correct answer. So that gets you up to 900.
Are we allowed to use calculator, by the way?
Sure, yeah, that's not a problem. All right, go ahead, Jason.
Inscribed 200.
Okay. Given the measure of DC is 60 and the measure of AB is 140, find the measure of DXA. Okay. So this will involve your triangle sum theorem.
Wait, am I DXA? Oh, DXA, sorry. I thought I said DXC.
Whoops. Oh, come on.
Okay.
Sorry, I'm trying to. All right, so. All right, so you got a wrong answer there, Jason. You got it right the second time, but we're gonna switch over to Gavin.
Yep, no problem.
Okay, Gavin, you wanna pick, so the answer is 80 because, 1 is 30, or no, 3 is 30, 1 is 70. So you subtract all that from 180 and you get 80, right?
Okay.
So 1 is half of this arc, 3 is half of this arc.
There's actually another way to solve this. It's a theorem 8.5.
Yeah, but then you would have to find, yeah, but that's the more complicated way. You certainly could do that.
Okay.
Yeah, you could do the averages of the other two arcs.
Yeah,
So yeah, that's the other way to solve it. But then you've got to find the measures of those arcs. So this way, you've got the arcs that you've got. Anyway, Gavin, go ahead.
Identify it 100.
Okay. Name the tangent line. Yes, Jason.
I texted.
Why don't you just tell me, because I'm having a hard time pulling up the chats.
Oh, DE.
Yes,
line DE.
That's correct. Correct. So line DE, it only touches the circle at one point, and we know that because the radius has created a perpendicular line to it, and there's no chord. It only intersects at one point. Whoops, why did that happen? We already did that one. Ah, come on. Sorry, I'm losing these. Okay, Jason.
Cruising at 200.
Okay. Give the reason why the measure of arc ABC is 29 degrees.
Can I just name the? Can I just say the name of the theory?
I'd rather you read it out loud.
Oh, okay. That's fine.
This should be section 5, right?
Right. So it is the measure of angle formed by two. I don't know what is that word called. By two SECANTS.
Seconds.
Secants.
Secants. Okay. The measure of an angle formed by two secants that is intersected in the exterior of a circle is when half the difference of the measure of the intercept arc.
Yep. Yep. So this was toward the end of that section. They might have a little video here. There we go.
Yeah.
From 8.5.3a.
Okay.
All right, so what I'm going to do here, you're up by 1,000, Jason. If you get up by more than 1,000, I'm going to toss it back over to the other team.
Okay.
Whoops, shoot. Keep having these problems. Okay, go ahead, Jason.
How long is it? 500.
How long is it? 500. If the perimeter of quadrilateral ABCD is 25, find the length of DF.
Raise my hand.
Yep, go ahead.
4.5.
That's probably right. Yes, that is correct. So, do you know how you got that answer, Gavin?
No, I don't.
So when you have tangents from a point exterior, the tangents are going to be what's the term I'm looking for? They're going to be congruent. So therefore, CG is going to be congruent with CH. So it's going to be 3. HB is going to be congruent with EB. You had this on your quiz, I think. EA is going to be congruent with FA. And so you're going to end up with 9 left. And FD and GD are going to be congruent. So they both have to be 4.5. Does that make sense, Harry?
Yeah.
So 4.5, because you got 9 left for that bottom left couplet of tangents there. So this goes back to, what is it, 8.4, I think, is where we had stuff like this. So that's going to put, okay, so Gavin, I'm going to throw the board back to you. Gavin?
Wait, I think it's freezed.
Oh. Oh. Harry, are you still there?
Yeah.
You want to pick one?
Okay. How long is it? It's 300.
How long is it? 300.
Wait, why can I see your screen?
Find CH if BE equals AF equals 12 and CE equals 8. So you got to find the missing leg of a right triangle. You know the hypotenuse, you know one of the legs, and you got to find the other leg. So basically, what? 8 squared minus 6 squared.
Is 2 squared 7?
I think it means square
yes,
root.
that's correct. Yeah, that's correct. So that's going to get you guys up to 500. All right, Harry, go ahead.
How long is it? 400.
If ED equals 5 and DF equals 13, give the length of the tangent segment. So again, same thing. Right triangle, you got a missing leg to figure out. And this is actually a Pythagorean triple, I think. You guys know that term, Pythagorean triple?
I think so.
Those are sides of right triangles that are whole numbers.
Right. I remember a couple of them.
3, 4, 5 is one of the most famous ones. This one's pretty famous too.
Mm-hmm.
But 3, 4, 5 is the basic one.
9, 12, 15, I think is also. Right, 9, 5, 15. 9, 12, 15.
And you guys got it? Well, right, 9, 12, 15 is just multiples of 3, 4, 5, right?
Mm-hmm.
But this is a different one. This is a different one. And you guys want to say hello to your teammate?
Where's Gavin, by the way?
Oh, here he comes.
Oh. Hi, Matthew.
Hey, sorry, my internet cut out for a sec.
Yep.
Hey.
So Gavin, we're on this Pythagorean triple. You got to find the missing leg of a right triangle.
Okay.
And it's a Pythagorean triple. So, Harry, you got it?
No.
$13 squared minus 5 squared, right?
Yeah.
Is it? Can I answer it?
Yep,
Is it 12?
that's right. 12 squared.
12 squared, right?
So I think this is the next smallest Pythagorean triple after 3, 4, 5. All right, Gavin, you want to go ahead?
Identify it 300.
Name the secant. Easy one, quick. Everybody got it?
Gavin, your face.
Sorry.
And your body.
Anybody got it? Come on.
Is it
Go ahead.
AE?
AE, or you could also call it AB.
AE?
You could call it AB.
Oh, AB, right.
They probably call it, I mean, I'm gonna give it to you, but they probably call it AB because those are the 2 points of intersection.
Right.
So you probably want to identify it by the 2 points of intersection. But anyway, Jason, you can jump back in here. You're only up by 500 now. All right, Gavin, go ahead.
Arcs and sectors 100.
For circle O, find the measure of, I'm assuming that's.
I think that's our case, AD.
AD.
Yeah, I'm assuming it's measure of arc AD and the measure of arc BCD.
Oh, those are arcs?
There's a font problem. I mean, the arcs and the central angles are the same, right? So it
Right.
almost doesn't matter. It's going to be the same value. So
Oh, somebody has to declare.
there's one little key to this that you have to spot, and then it's pretty easy.
Is AC the how do you call it? Diameter?
I think that's a good assumption. I think that's a safe assumption.
Right, because sometimes my eyes is some problem. That B, C, D.
Go ahead, Gavin.
Is AD 130 degrees and what's the other one? BC, oh wait, BCD, never mind. Well, no, I could still do it.
Measure
Oh.
PCD is
205?
205?
Yeah,
Okay, say it again. So the first one you said was 130.
right. The next one was 205.
I'm not so sure about that. Oh yeah, you're right. Sorry. Good job. Good job. For some reason I thought it'd be 230. Oh, but I was forgetting the 25 degrees. Yep. Good
Right.
job. All right, so you guys are up to 1300. So you're catching up here.
Sweet.
Well, hold on, Matt. What is my score?
You're at 1700. So you better jump back in here if you want to keep on top.
Okay.
Go ahead, Gavin.
Inscribed 100.
All right. Given the measure of, let's call that arc AD 98 degrees, and find the measure of arc ACD.
Find the measure of arc ACD. If AD. That's measure RAD, right? Oh.
ACD. So it's the major arc.
I think I got it.
Yep. Go ahead.
Is it 262 degrees?
Yeah, that should be right. Yep. It's kind of a trick question because you got all those angles in the middle,
Right.
right? They're just trying to throw you off with that by using the same diagram. But this is a 100 question, so it's fairly easy. Good job. All right, go ahead, Gavin.
Circles 100.
All right. Given this circle, name the center and radius. Easy.
Okay, I raise my hand.
Go ahead.
The center is 4, negative 16, and the radius 5.
That's right. 4, negative 16. So again, you just flip the signs, and then you do the square root of the right side. So very easy. Go ahead, Jason.
Inscribe 500.
Stay sharp, guys. If the measure of arc NOP equals 218, find the measure of angle NRM.
NOP. Wait, NOP this. Oh.
Oh.
Go
In a
ahead.
little bit.
Go ahead, Gavin.
Is it 71 degrees?
So this is inscribed 500. No, it is not.
Oh, and
Where is NOP? Oh, NOP.
You have to find that center angle, which is not an exact center angle. I mean, it's an interior angle, right? NRM. So you have to remember the theorem about opposite angles in an inscribed quadrilateral. So Harry, I'll let you answer this one. We probably have to give Jason a chance first.
95. I assume it's wrong.
What is it again?
95.
Right, that's incorrect. Harry, why don't you take a shot at it?
Which step is wrong? NOP.
This is not an easy one, that's for sure.
Wait, give me a second. I want to draw a diagram on my paper, so it'll be better for me to, well, actually, NOP. By the way, that's a measure. That's arc NOP, right?
Right, arc NOP is 218. Because you can't really have angles that are more than 180. At least we've never used them in this book, right? $23.5.
It is really hard that I can only look at the screen. That
All right, so
wait a second. Almost.
If that's 23.5 and that's 20.5. And therefore, NPN has to equal 122.5. So therefore it has to equal, boy, I need my calculator. Let's see. 80 minus 57.
47.5.
That's too small.
Too small. Okay.
I mean, you can sort of see, you know, again, it's not exactly to scale, but you can sort of see that it's an obtuse angle, right? Because it's almost
Right.
so 57. All right, so NM has to equal 115.
Oh.
75.5.
All right, so that's 47, and that's 115. So 3.
What did you say, Harry?
Nothing.
Okay.
119.
Close.
190 isn't. Oh my.
Well, I mean, this thing could be wrong. I don't know.
That shouldn't. Let me check again.
You know, the problem is if I escape out of this to look at they have some
Wait,
discussion.
I almost got it. Wait a second. Wait a second.
Yeah, I'm pretty close too.
Oh, I made a mistake.
Okay, wait a minute. MOP is 23.5. MPM is 57.5. So that's 115.
114.
That's right. How'd you get it?
You make a line. You gotta draw a line from N to NQ. You gotta draw a line from N to Q, and then you have a what do you call that triangle?
A right triangle?
No, not the right triangle, because it
Oh,
is
an
95.
isosceles triangle.
So you separate you do 180 minus 95 and divide by 2. You got NQM and the QMN. And you have an inscribed angle, which is N and P. So you use NQM Q and M and subtract P and M. So you got the Q and P. And then you know the NQM is what, 95 degree. So from the what do you call ulterior angle? I forgot what the name called, but as long as you know.
Interior angle.
Yeah, interior angle, and so NRM is 114. Do you understand? I probably don't explain very well.
I was trying to find all the different arc measures and then do the average of OP and NM.
I don't think there's any way to know where the measure of arc and O.
Yeah. I think another way to solve this has to do with the fact that the opposite angles are supplementary in an inscribed quadrilateral. So if NMP is 109, then that means that NOP has to be what, 81? And that means that arc PMN would be 162 minus 47. Is that right?
Right, but even you got that, but there's no. I think the key arc is NO, but
Yes.
even
Yeah.
you got the arc, even you got the measure of arc, and
right, because then you can do the average. You can do the average of NO and MP, and then you do the supplementary, right? Because it's a linear pair. NRO is supplementary with NRM. So, yeah. So I'll give you half for that since it took so long. So that gets you up to 2,050. And I'll give you the board.
Circle 500.
Okay. Find the equation of the circle with an area of 196 pi centered at -1, 5. So again, the left side of the equation is very simple. It's the right side that can be a little.
Let me raise my hand first.
Well, you have to give the answer right away if you're raising your.
I'll give you right now. It is x minus x plus 1. I just text you.
Yep. Go ahead. X plus 1 squared.
X plus 1 squared plus x minus 5 squares is 14, equal 14.
The equation you're giving is 14.
No, I mean, Yeah, equation is x plus 1 squared plus y minus 5 squared equal 14.
No, that's not right. Gavin, you want to
109,
try it? Go ahead.
x plus 1 squared plus y minus 5 squared equals 24.81, roughly.
No,
Because
no.
that's the square root of 196.
Harry, you want to try it? This is really simple, actually. All the info is right there on the problem. Harry, you want to try it?
No.
Okay, it's x plus 1 squared plus y minus 5 squared equals 196. Remember, the right side is r squared. So
why am I solving for radius? Oh.
Pi r squared, you're just dividing out pi, and it's r squared, so it's 196.
Why am I solving for radius?
All right, Gavin, the board goes back to you.
Reason at 100.
Okay. Give the reason why the measure of angle ABC is 62 degrees.
I raise my hand.
Go ahead.
The measure of the angle formed by the tangent and secant that is intersect at the point of the tangency is 1/2 measure of the intercept arc. Theory
Right.
8.5.1.
Right. So this showed up on your quiz, and a lot of people got messed up because there was like another segment drawn that made it a triangle, but you had to focus. This was on the 8.5, I think. This is just another form of an inscribed angle, right? Only instead of being two secants that are the rays, it's a secant and a tangent, but it's an inscribed angle at point B, and so you're just dividing it in two, just like you do with all other inscribed angles. You know, an angle whose point of origin is on the circle, okay? All right, so that's 2150. Yeah, so this is from section 5. Go ahead, Jason.
Arc is sector 500.
Platform floor is built at the base of a tunnel as shown. Find AB and the measure of ACB.
ACB.
So this is pretty tricky. You'll have a couple different equations that you have to do here.
He mean measured AB, right?
What's that?
He mean measured AB, right? And the measure of arc ACB.
Right, right. So segment AB, which is the hypotenuse of that triangle, and arc ACB.
I raise my hand.
Go ahead.
So the AB is 5 square root 2, and the measured arc, the measure of arc ACB is 270.
Well, no, they're asking for the angle. No, I'm sorry. They're asking for the arc.
Yeah.
You're right, the arc.
That's what I got too.
So the arc is 270?
Yeah, that's what I got for the arc.
What are you saying the arc is?
270. 270.
265? No.
Well, they've got quite a different answer here.
270.
Again, it's just hard to know what that symbol. It's hard to know what that symbol is. If it's, well, it can't be an angle because they're giving me a distance. So I think what they're asking for, they're asking for the length. Well, no, it says measure, right? Oh. So what they're saying is it's the measure of this major arc, ACB. So it's the major arc. So it's the measure, it's the length of the arc ACB. In other words, minus AB, minus arc AB. What did you guys get again?
170.
Wait, I'm confused. What does that mean?
Well, so you said it was what was AB again? What you say
AB
AB was?
is 5 square root 2.
Right, 5 square root of 2. That's right. Very good. It's a 45. It's an isosceles triangle, right? So we learned about this in chapter 7.
Right, 45 right triangle, and
Right, 45, 45, 90.
measure ACB is 270.
And yeah, they've got a much smaller answer here.
That can't be. ACB is not a small.
They've got an answer of 15 pi over 2 feet, 23.6.
I think he meant the area.
You think you meant the area?
No, I think they meant the area. The
Well,
area.
no, because they don't have a square feet. They don't have a square feet.
What unit they have? Or
they've just got 23.6 feet.
And
So-
I think it's I think
this
it's
is
asking for that.
So this is about a tunnel, and you need to find the distance of the tunnel, right? AC is.
I think I understand now.
So this is about the formula, right? The length formula, which is length equals what? Theta.
15 over 2 pi.
Right.
Feet, yeah?
Right. So it's theta r, or wait a minute, theta. So this is a circumference, right? It's a circumference. So the formula is in is it section 5 or section 4? All right, so the formula is on page 361. If the arc of a circle with radius r, and so the radius is 5, right, has a degree measure of theta, and the degree measure would be 270, right, for the major arc, 360 minus 90. So it would be 270 times 10 divided by 360. Does that sound right? 2,700 divided by 360.
Yeah, that's what I did.
Which gives you 15 pi. Whoops, we forgot the pi. So 2,700 pi divided by 360, which reduces down to, so those are factors of 9. That's 15 pi over 2.
Right. I got it second time. The second time I got it.
So, all right.
It isn't really my fault because it didn't declare what is that. I thought it's
Well, it's the measure of arc ACB, which again is you have to think of it as the walls of the tunnel, right?
Yeah.
This is the floor. AB is the floor of the tunnel, and then ACB is the circumference of the tunnel.
Yep.
So I'm going to give you 250 for that, Jason. So that gets you up to 2,400. So there it is.
Oh, okay.
So again, this was the formula on page 361, section 8.3. It's the theta formula where you've got to know the measure of the angle, you know, in order to find the length of the circumference. All right, go ahead, Jason.
Identify 500.
All right. If BC and BG are tangents, classify quadrilateral ABIH.
BC.
Easy, ABIH.
Oh,
Go ahead, Gavin.
is it a kite?
It's a kite, right? Because the two radii are congruent and the two tangents are congruent. So AH is congruent with IH, AB is congruent with IB, and so therefore it is a kite. So that jumps you all the way up to 1900, and you have the board.
Identify at 400.
Okay. What circles are externally tangent and internally tangent? Easy.
I remember doing this. I just
Goes all the way back to like section 2, I think, or maybe section 1. I'll give you a hint. They're all on the right side. They're all on the right side. Tangere, Latin for to touch.
Extremely tangent. Externally tangent. Internally tangent.
internal would be.
Internal, I think it's AB.
Anybody got it?
And 6.
B8 is internally.
Harry, were you answering there?
Internal tangent is
Yeah.
AB. External tangent is BC. BC.
Say okay. So internal was
AB.
and external was
BC.
very good, very good. So remember, there's a difference between tangent circles and tangent lines between circles, right?
Oh,
So this is not referring to that line at the bottom. It's referring to the circles that actually touch. Okay, and so yeah, as Harry said, B and C are externally tangent because they're on opposite sides of a tangent line that would pass between them, whereas the internally ones, A and B, would be on the same side of a tangent line that would touch them. Okay, so that gets you guys up 100 behind. So we're getting a little tight here. This is good. This is good. Go ahead, Harry.
Circles 400.
Sectors or
Circles.
circles?
Circles.
Circle, I mean.
400 or 300?
400.
Okay. Find the standard form equation of the circle and state its center and radius. So this is about completing the square. Completing the square. So that's in section 8.7. Page 388.
I have the answer.
Okay.
X plus 4 squared plus y minus 6 squared equal 52.
it happened again.
x plus, say it again, x.
X plus 4 squared plus y minus 6 squared is equal 42. I mean,
Okay, so you've got half of it. Now you need to get the center and the radius.
oh, the center is -4 and 6.
Okay,
-4, 6, and the
okay,
radius is square root 52, which is 2 square root 13.
very good, very good. And this is a double up, so that jumps you all the way up to 3,200. All right, so do you guys know how he did this? You got to do, oh, Gavin, we lost Gavin. So we do x squared plus 8x, and then we have to do b, which is the 8, divided by 2, right?
Mm-hmm.
And then we do y squared minus 12y, and then we do b, which is the 12, divided by 2. And that's what allows us to form our binomial. And then since we added 4, right?
Mm-hmm.
So Gavin, I was just talking about how we do the completing the square. So we have to add those figures to the right side, and we have to square them, right? So it'd be 16 plus 36, right? 4 squared, 16, negative 6 squared, 36. That's what gives us the 52 on the right side. And then we use the binomials to find the center, and we use the right side. We take the square root of it to find the radius. And all right, so Jason, you've got the board.
Reason is 300.
Give the reason why the measure of XYZ is 87 degrees.
The measure of the angle formed by an intersection of two tangents is 1/2 the difference of the measure of the intercept arc. Theorem 8.5.3c.
So this is basically the same as the other external intersection angle. It's just that they're tangents now instead of secants, right? So that's why you had 8.5.3a, or maybe it was b. Now we've got 8.5.3c. So, all right. All right, Gavin, he's up 1,000 again, so I'm going to throw the board back to you.
Arcs and sectors 400.
Find the arc measure if the sector's area is 128 pi divided by 3 and the arc's radius is 8 centimeters. I'll give you a hint. It's a major arc. Major arc. Part of this is finding that arc length, right? That theta formula.
Huh? Oh, well.
Yeah, there were some problems related to this on page 366.
What page did you say?
366, there were some problems in the book related to this. Like problems 22 to 28. You got to use that formula on page 361, or look at example 3 on 362.
I have the answer.
Go ahead.
240.
Why don't you tell us how you did that?
I actually make the function, equation. So I set
Okay.
up an x, like 64 square, which is the
Yep.
the radius, the area of the whole circle, times x over 360 equal 128 pi over 3, and then you solve for the equation.
So that's kind of similar. Yeah, that's kind of similar to that theta formula where you got to divide by 360. Yeah, I'll see if there's because some of the answers here, they have discussions of them later. All right, Gavin, you get the board again.
Inscribed 400.
If the measure of, let's assume that's arc NM is 95, find the measure of NMP.
We did this, right?
What's that?
We did this.
No, this is the same figure, but now they're asking you a different question. Figure. This one's actually easier, I think.
Right. It's much more easier.
Again, you got to remember that opposite angles are supplementary when you have an inscribed quadrilateral. Once you know that, this is pretty easy. Yep, I got it. So NM is an arc, right? It's that arc on the left side.
Right.
How you doing, Harry?
Mhm.
What were you? You didn't talk today.
Everybody got it? All right, 10 seconds. It's not that hard.
That's not right.
Everybody got it?
38 degrees, which doesn't seem right.
All right, you add arc MP and MN, which gives you 142. That
Right.
gives you the measure of inscribed angle NOP, which would be 71. You know that the opposite angle NMP has to be supplementary, right? Because that's the way, there's a theorem that says that in inscribed quadrilateral, the opposite angles are supplementary. So you just subtract 71 from 180, and that gives the answer of 109. Make sense?
Yeah.
All right, go ahead, Gavin.
Circle's 300.
Find the equation of a circle given that its center is -3, -6, and the circle passes through 0, -2. So you got to use the distance formula to find the radius. And what's easy about this is that you don't have to do the square root, right? Because you need the radius squared in the equation.
Oh.
Right?
Yeah, the equation. Okay. Is it can I answer?
Go ahead.
X plus 3 squared plus y plus 6 squared equals 5.
Well, remember the formula, the right side has to be squared as well.
Okay. Oh, well, the square root of 5. Which
No,
is what?
no,
Oh, squared. Right.
right,
So 25.
right, 25. Sorry, just a second. Okay. So Jason's still up by 1,300. Go ahead, Gavin.
Reason at 500.
AB and CB are congruent.
Oh, by the way, I have a question. Are we gonna explain it by telling what is the theory it is, or we can just explain it in our own words?
Well, if it's well reasoned, if it's well reasoned, you know. This is one of those transitive ones. About arcs and chords and central angles.
Uh-huh.
In fact, you had a homework where you had to plot out the transivity of this, and a lot of people didn't get it correct because they
Incongruent circles. 2 chords are congruent if and only if they are equidistant from their centers. Is that the one?
no. This is in section 2. Well, 2 or 3. I think it's in 2. I think this is section 2. It's the one on central angles. Yeah, there it is.
Oh, incongruent circles, chords are congruent if and only if the corresponding central angles are congruent.
Chords are congruent if and only if the corresponding central angles are congruent. That's correct. That's correct. And that's because you know that the arcs are congruent, right? Arc AB has to be congruent with arc BC because their central angles are congruent, and therefore segment AB has to be congruent with segment AC because it's the same circle. So you know the arc length. Oh, anyway, yep, that's it. That's it. In congruent circles, chords are congruent if and only if the corresponding central angles. And the if and only if is why you have the transivity, right? So that still not too close, but maybe final Mathardy you'll get it. Go ahead, Gavin.
Reason at 400.
Give the reason why segment AB contains the center of the circle.
Oh, the line and a plane of a circle that is a perpendicular bisector of a chord contains the center of the circle.
Very good. Very good. 8.1.3. So getting closer. All right. Go ahead.
Arcs and sectors 300.
Find the perimeter of a 60-degree sector with an 8-mile radius.
I have the answer.
Okay.
Oh, wait. No, I don't have it. Wait, I do. Wait a second. I
The
do.
perimeter, not an area. A perimeter.
I do. Yeah, I do have the answer. So
Yep.
it's 8/3 pi
Yep.
miles. Is that right?
Say it again.
8/3 pi miles.
No, that's not correct.
Oh, yeah. Okay.
That's the length of the arc.
Yeah, isn't he asking for that?
Find the perimeter of the
Perimeter.
sector. The perimeter of the sector. So you let them try answering it before you try again, okay?
Okay.
You forgot the easiest part of the equation.
Find the
Harry, you got it? Perimeter of a 60-degree sector with an 8-mile radius?
parameter. Find the parameter of 60. Oh, parameter.
Yeah.
Oh.
If you think of a triangle, you only gave one of the sides of the triangle.
I see. I see. Oh.
Got the other two sides.
I
Is
see.
it-
I see. Why not?
24.37.
That's correct. That's correct. Yeah, so you forgot the 2 8s. You forgot the 16.
Yeah. Yeah. I know.
Go ahead, Gavin.
Inscribed 300.
Given circle Q, find the measure of angle MNO and the measure of angle MNP.
Oh, so we did that question without doing those previous questions. That's why it took such a long time.
This one's pretty easy. This one's pretty easy.
And oh.
Twenty seconds. This is easy.
Is
Go ahead.
Is it 23.5 for MNP and then 66.5 for MNO?
You got one of them right.
Yeah.
Oh wait, you
MNO is
add both of
90
them.
What's
90
that?
degree. MNO is 90 degree.
What's
Yeah.
that?
90 degree.
It's a 90 degree.
Yeah,
Yeah.
see, MNO intersects a semicircle, so it has to be a right angle. Okay. So I'll give you guys 200 for that one. So now we go into final Mathardy, and we've got 4,000 for Gavin and Harry and 3,900. So you guys need to write down on a piece of paper what you're bidding.
Wait, what is my score, by the way?
3,900,
And theirs?
4,000.
Okay.
You can bid as much as you want, and I also want you to text it to me privately so that I've got it confirmed. Okay, so text it to me privately, and then write it down on a piece of paper.
Oh,
Just text it.
Okay. Gavin, you got yours?
I'm sorry, how much do we have?
You got 4,000. You're 100. You're 100 ahead of him.
Okay. I don't know, how much are we gonna bid, Harry?
No. That's all in.
You guys can text each other privately if you don't want to tell. Well, he's already, Jason's already given his, I guess.
Okay.
It is actually, my answer is actually about what is doing something meaningful. It's just like something divided by zero, it's meaningless. So that's why I gave
It's one of these things where you could like risk everything but 100,
Right.
and if you both get it wrong, you should still win if he bid all of it. So there's different strategies if you've ever watched Jeopardy. You guys got it?
I think so. Harry, did you get my message?
Yeah.
Okay. Does that sound good?
Yeah.
Okay. So I sent it
All
to you.
right. Ready?
Yep.
Here we go. Find the perimeter of a segment formed by a 120-degree sector with a radius of 6 inches. So in a sense, you already had this one earlier.
And the perimeter of the segment formed by. Well, he's asking for the arc or for the sector?
The perimeter,
perimeter.
of a segment. The perimeter of a segment. So make sure you know the difference between a segment and a sector. Make sure you know the difference between a segment and a sector. So if you want some help, if you go to 362 in the book, we had an example of this. So a segment is just the part that connects the chord and the arc, right? So in a sense, you've got to find the length of the chord.
Oh, I know.
And you've got to find the length of the arc. Okay. So page 362.
Six square root 3.
Is that your final answer?
Yes.
Okay. So that's incorrect.
Okay.
24.56.
That is also incorrect. Harry, what'd you get? So Jason, you had part of the right answer, but you forgot, I think, to put to give the arc length.
Did he ask for arc length?
Well, you have to
You
have
have to find
a
it.
segment a segment, you got to find the chord length and the arc length. So you've got to find the missing leg of a triangle, of an isosceles triangle. You know, so two of the lengths of the sides are 6 and 6, but then you got to find that other length. But then you've also got to find the length of the arc.
Oh, so the answer should be include the segment and the arc.
Right.
Oh, I didn't
Well,
understand.
the segment. So the segment is, you know, the perimeter of it is the arc plus the chord. So if you look at the one on page 362 at the bottom,
Oh, I see.
the perimeter is arc XY and segment XY.
I think.
Or,
Okay. I see.
or yeah, segment XY. So that's, so it's using the term segment slightly differently than we're used to using it.
Can I answer it again?
Sure.
Or no chance. 6 square root 3 plus 4 pi.
That's correct. That's correct. But you didn't get it right the first time.
Right. That's why I asked.
So how much did you bid, Gavin?
500.
How much did you bid, Jason?
All of it. Actually, infinite.
All of it.
It's actually infinite.
So, like some of these have discussions here. I thought some of these did. I thought some of these had discussions in the solutions to hard problems can be found in the notes on the PowerPoint file, except that I'm not seeing the notes here. Slide sorter, no. Notes page. Ah, here we go. Whoops.
Oh, I see something.
Can you guys still see this?
Yep.
I mean, I can, I'm not sure why though. Notes master, no. Some of these are supposed to have discussions on them, but I'm not sure why they don't. Anyway, so victory. Good job, Kevin. So you guys will get +10 on the test, and Jason, you get +5.
Okay.
All right. This took.
Why I lose? How did I lose in final Mathardy?
Because you bid all of yours, and so they ended up with 3,500. You ended up with 0.
Wait, I got the correct answer, right?
Yes, on your second try.
And it didn't tell.
You got the correct answer, but on the second try. So I can't give you credit for that. Anyway, it's no big deal. You guys are going to do fine. So anyway, by the end of today, I am going to scan and upload the test, and I'd like it turned in by Thursday. So,
Okay.
All right.
What's the homework for today?
It's just the test. It's just the test. Chapter 8 test. Okay.
Okay.
All right. Good to see you guys. Take care.
You too.
We'll try this again sometime.
Okay.
All right. Bye.
Bye.